Hello, everyone. There's exciting news that's dropped. We have more details about the Tesla Dojo chips and data centers. Uh, Everyone on the Tesla community has been wondering what's happening with the Tesla Dojo. And now we have that information, and we'll discuss that with Randy Kirk, and we'll get into some presentation of the information, the breaking news. So Tesla Dojo is Tesla's AI training chip, and it competes with the Nvidia chips. Tesla uses both those chips. So the Dojo system, which people may have forgotten, is made in tiles. This is a tile, it's about a square foot, and it's about 5 by 5 in terms of like these D1 chips. An entire tile produces 9 petaflops of compute operations per second, and it uses about 15,000 watts, 15 kilowatts of power. And you put 120 tiles together and you have 1.1 exaflops. So how does that compare? Tile versus an Nvidia H100, which is the current leading Nvidia chip. So the 9 petaflops, 25 chips, 15,000 watts versus 2 petaflops at floating point 16, slightly bigger bit. Smaller words, floating point 8 bits is 4 petaflops at 300 to 700 watts. So you're looking at for a little over 4 times the petaflops, you need on the order of 20 to 40 times more power, which is a lot more power, right? So it's basically, if you were to equalize the power, then you're looking at 5 times less efficiency. And then this gets worse with the B200, which is even more powerful, which is the chip coming from NVIDIA, although it won't be at scale till next year. 1,000 watts, up to 20 petaflops, floating point 4, so even smaller words. Again, but Tesla is getting a version 2. They're about to end the version 1, and then they use the version 2. For a large system, 45 exaflops, and then you're looking at 125 megawatts of power. And then 40,000 NVIDIA chips, 800 chips, which is about how much we think Tesla has claimed that they have in the last quarterly report, at the 160 exaflops at the end of 20 megawatts. So the reason Tesla hasn't gone all in on this thing is because they use a lot more power and they're getting less out of it until they make the next versions of their chips. But and then we'll need to scale this stuff to larger amounts of power, B200s or that, and we'll get to huge amounts of compute. So this is something they need more and more of, and energy is one of the limiting things. There's the startup called Etched, and they're working with TSMC. They claim to be 10 to 20 times faster than NVIDIA's B200 chip, the next generation chip, and only leaving 10 watts of power while delivering super high performance. So how do they do this magic?
Yeah.
They use application-specific integrated circuits. So ASICs have been around for a long time. So basically, I have my program on circuits that I can actually program in the hardware. So currently, most of our computer chips or laptops or phones, they have standard computing processing units, CPUs. And you have operating systems, you have all this compilers, all that software to communicate your intention, your programs to the chips. You lose about 200 times the efficiency on that. So when you go direct onto hardware and say, it's way harder, but we're going to program direct on the hardware, you can get this 200 times improvement. GPUs are 10 times more efficient or whatever than CPUs. You have to write all this software for the GPU that's parallelized, because parallelized. So I'm doing 200 operations, 1,000 operations at the same time, right? So that's the accelerated computing. Difficult to do, which is why NVIDIA has the lead, because not only have the chips, the GPUs perfected, but they have these programming libraries to convert. I want to solve AI. I want to solve chemistry. We have this programming stack to run the parallel stuff, right? So then these guys have chosen to do only transformer model AI models on their chip. So they're saying, we're only going to do transformer models. You can't do any other kind of AI on the thing. And if you change your transformer model, we'll have to re-hard code the hardware, right? So we're doing hardware-specific custom chips. This is what that thing looks like, right? So, but the rest of the IT world knows this too, right? So future Dojo could choose to optimize and say, we want to do a specific kind of transformer. We don't want to do the transformer that we're using at XAI. Then they can get that kind of efficiency, right? And Soho is doing it like 20 times faster than H100 in terms of like how many, if I run the Llama model, how many I need to get however many tokens per second or something like that. Basically, whatever the metric is, 20 times faster potentially. On
So,
the chips.
let me interrupt you at this point
Yeah.
because this is my job on this channel. My job is to be stupid. Okay,
Yeah.
it's really easy for me.
Yeah.
Um, so why wouldn't you be doing both? Why wouldn't there be applications where you need that generalized solution, where you'd be willing to give up the efficiency, and other circumstances where you'd be willing to give up the fact that it's going to be hard coded forever in a certain way in order to generate the efficiency?
It's a substantial commitment. You have to basically say, this is the way I want to go a year, 2 years ahead. Like that startup had to take 2 years to do it and then
Right.
commit to it. And then when you make these big architectural choices, then it's, you're if you're wrong, then you're screwed, right? So basically, you're saying, here's the bets we're making a few years ahead of time. We think we can do this, get whatever efficiency, and then make the choice. So then, the H100, the plans were laid years in advance to it, and they're committed along a research track where all the people in the R&D of Nvidia
Mhm.
are geared towards doing it in a particular way,
Right.
right? And then they also probably didn't believe, oh well, we want to give this up for whatever thing. The whole ChatGPT thing that only happened like 2 years ago,
Right.
right? So it had to be a bunch of startup people willing to work night and day who committed basically once ChatGPT broke, or as ChatGPT was breaking 6 months ahead of time, and realizing this is the way to go. And then then there was 3 years ahead of time. But if
So,
you're saying what will you do in 3 years, then maybe they can do this. Yes.
so yeah, I think I understand what you're saying from the hardware development side, but what about from the buyer side? So I want to buy these from you in order to put them in my data center and then get them rolling along to create whatever results I'm looking for. Why wouldn't I have one row of NVIDIA's and then one row of Sohu's, because the Sohu's would be good for this and the NVIDIA would be good for something else.
Because there's more to it than just the chips sitting there. Let me um, stop sharing and then switch over to see if I can get my uh, there it is. Are we seeing which screen are we seeing here? Stop sharing.
Sohu is 20 times faster.
Okay, so I need to get to a different one. I need to go to okay. Okay, so in the if we're seeing the Dojo chips and stuff, there's a bunch of wiring and networking and stuff, right? So they have the racks and they have different systems in there. Well, one, it's in order to get to 4,800 tiles, there's 10 tiles per rack. So then I would need to have a data center full of like 480 racks of it. So it's a large amount of compute. Same thing for the NVIDIA chips. It's many, many racks. So you can say one rack of this, one rack of that. But then they have different networking. So one of the things announced at the hot chips thing is that Tesla transport protocol. So they redid the entire fundamentals of how they network and communicate, and it's twice as fast as the NVIDIA version. And they're each 100 times faster than TCP/IP, which is traditional networking stuff. So there's a bunch of wiring that they're doing in order to get the chip to communicate, right? So if I'm mixing and matching stuff together, then I have to do a bunch of complicated things with how I network and put the stuff together, because there's a lot of complexity in that. So it's like get down to yeah. So then they have the Dojo engineering system. So then I have the cluster, I got the local storage, you got the cores, I got the I/O, right? So I have this architectural model of what I'm
Uh,
doing. So if I'm mixing and matching stuff in there, that
uh,
model gets more complicated, right? And also things could mess up. It's like I'm not cookie cuttering and saying this will talk to this, this will talk to this. And repeat the same thing over and over, get the wires done up like that. There's a bunch of complexity to it. And then it's just like I'm running the software, I'm running my microphone here. I wire it up wrong and the things don't work, right? So there's a bunch of time to, and that's a relatively simple thing. This is more complicated. You
sure.
can screw up way more ways. That's why it takes months for really smart people, many of them, to get these things up and running,
Got
right?
it.
And then also there's things like how things cool, how things power. Elon had a problem where they make their 40,000 H100s run together, and then things would crash when I'm running a program. Suddenly I stop running the program. So I was using 20 megawatts and then suddenly it dropped to zero.
Yeah.
And then that broke stuff. So there's a lot of engineering, and these things are just difficult to operate properly.
Okay.
So yeah. So any other questions about that?
That's it. That's it for now.
Okay. So basically then there's a lot of work going on Dojo. They've said that they have at least 4 exaflops of that, and then they were making like a 9 exaflop facility. So if we have 160 exaflops of Nvidia chips at Tesla, then if they're at 4, then they're at 2 at 3-4% of the compute power and then Dojo side of things. But if they go to version 2 and they scale up and they have $1 billion data center, and then they could get to significant percentages of Dojo. But they have to do a redesign, which they're in the process of doing to get version 2 out, which we have no details about. And then they're working on version 3 of their Dojo. But they're networking, they're doing the hard lift of matching and exceeding the NVIDIA chips. And then if they choose to be more focused around, like, say, only transformers or only the XAI solution, then they can choose a easier problem than NVIDIA is doing, which could, at Etched showed, gain benefits because the Etched team is smaller than the Tesla team, right? So you can get out ahead. You just have to choose the right technological choices there.
Okay. All right.
Yeah. So basically, that's an update on Dojo, that it's still a major commitment from Tesla, and it's something that's making substantial progress. I think version 2 or version 3 is a level where they will get substantially closer to what NVIDIA is doing. And especially there's huge gains to be made by doing custom chip approaches like the startup Etched. And those startup Etched chips are being produced by TSMC. So you still go to the same production facility on that. So Tesla's chips, Etched chips, NVIDIA chips, all being made at TSMC on that. So
Okay, so then Elon has really actually recently recommitted by saying that, you know, he still thinks that they can be competitive with Nvidia in the future. So he believes it. If Elon believes it, I generally believe it.
right, and also as we've seen with Etched, there's choices that they can make where they can get huge amounts of compute and get the efficiencies that they need. Like, the technology is there, the industry is working on it, and the other factor is that NVIDIA chips have 75% margin, where basically their cost is actually 4 times less than what they're charging people, but they charge people 4 times more because they're so far ahead.
Yeah.
So if you get within the range of NVIDIA, then it's, if I'm making a chip that's only half as good, then it's totally worth it to me. If I get it 1/4 as good, then it's worth it to me, as long as the energy usage is reasonable, because then that's a cost that
Goes on and on and on.
goes on and on. Yeah. Right. Okay. So that's the update on Dojo, and we'll discuss more about Tesla and things next time. Thank you.